Hello everyone, welcome to Neso Academy. So far we have completed 3 chapters in VHDL. In those chapters, we learned about Introduction to VHDL, Structure of VHDL and VHDL data objects and data types. Now today we are starting our 4th chapter, VHDL operators and statements. And in this lecture, we are going to begin with operators, especially arithmetic operators. And in this lecture, we will cover the following topics. The very first topic is operators. In this, we will understand what are operators. And the last topic is arithmetic operators. In this topic, we will understand what are arithmetic operators and its types. So, let's start the lecture with the very first topic, operators. Now, what are operators? Operators are symbols or keywords used to perform operations on data. Means operators are symbols or keywords which are used to perform operations on data values. Data values such as constants, signals, variables, numbers, etc. So, operators are symbols or keywords which take multiple input values and perform an operation. And these input values are called operands. So, operands are the data values on which an operator performs an operation. Example 2 plus 3. Here 2 and 3 are operands and the plus symbol is our operator and the whole process is called as operation. Now operators work on one or more operands. Means operators work on one or more data values. Just like we saw 2 plus 3. Here we have 2 operands. Similarly, in VHDL, we can have one operand based operation. Example, not of 101. Here, 101 is a single operand. Next point. Operators help us describe hardware behavior in a simple and readable way. That is, operators make it easier to describe how a digital hardware works in a simple and readable way. That is, instead of drawing complex circuits or instead of writing complex codes, we can use operators to describe hardware behavior using symbols and keywords. And in VHDL, operators are of mainly 6 types. They are arithmetic operators, logical operators, relational operators, shift operators, concatenation operator, and miscellaneous operators. And today we are starting with arithmetic operators. So I hope you understand what are operators, which means we are done with our first topic, operators. Now let's understand second topic, arithmetic operators. Now what are arithmetic operators? As the name suggests, they are used for mathematical operations. So, arithmetic operators are used to perform mathematical calculations on numbers or binary values. So, arithmetic operators perform calculations on numbers, signals, variables, constants, just like normal mathematics. So, arithmetic operators help us perform arithmetic operation. And in VHDL, there are 7 types of arithmetic operators. The first type is addition operator represented by plus symbol. Second, subtraction operator represented by minus symbol. Third, multiplication operator represented by asterisk symbol. Fourth, division operator represented by forward slash symbol. Fifth, modulus operator represented by mod keyword. Sixth, remainder operator represented by rem keyword. And the last, exponent operator represented by double asterisk symbols. We will understand each of them. First, start with addition operator. Now, addition operator is used to add 2 or more values. That is, addition operator is used to add 2 or more input values. Now let's see how to use the addition operator inside a VHDL code. For that, I am taking a signal named A with integer data type and assigning a fixed value 10. Then I am taking another signal which is also an integer data type, and assigning a fixed value of 5. Now I want to add these two values and store the result inside another signal. Example, sum, which is also an integer data type. And why integer data type? Because here I am adding two integer values and the result will also be an integer. Now let's see how to use plus symbol to perform the addition. Here I am assigning A plus B and storing the result inside this sum signal. So this sum signal will have the value 10 plus 5 equal to 15. So I hope you understand how to use the addition operator. Let's understand the second operator, subtraction operator, represented by minus symbol. Now subtraction operator is used to subtract one value from other. That is, subtraction operator is used to subtract one input value from other input value. Let's understand how to use the subtraction operator in VHDL code. For that, I am taking two signals, A and B, and both are of integer data type and assigning fixed values. Example, A equals to 10 and B equals to 15. Now I want to subtract 15 from 10, that is 10 minus 15, and store the result inside this signal diff, which is also an integer data type. Now let's see how to use the minus symbol to perform subtraction. Here I am assigning A minus B and storing the result inside the signal named diff. So the signal diff will have the value 10 minus 15, which is equal to minus 5. So I hope you understand how to use the subtraction operator. Now let's see the third operator, which is multiplication operator, represented by asterisk symbol. Now multiplication operator is used to multiply two or more values. That is, multiplication operator is used to multiply two or more operands. Now let's try to multiply three signals. For that, I am taking signals A, B and C. All are of integer data type and assigning fixed values. Example, A equals to 2, B equals to 3 and C equals to 4. And declaring signal named mul with integer data type to store the output. Now let's understand how to use the multiplication operator. Here I am assigning A multiplied to B multiplied to C and storing the result inside this signal mul. So this signal mul will have the value 24 equal to 2 multiplied to 3 multiplied to 4. So I hope you understand how multiplication operator is used to multiply two or more operands. Now let's see the fourth arithmetic operator, division operator. Now division operator is used to divide one value by other. That is, division operator is used to divide one operand by another operand. In normal division, when we divide a dividend by divisor, we get two results, quotient and remainder. And division operator will give us the quotient as output. Now let's understand this using an example. For that, I am taking two signals, A as integer 23 and B as integer 5. Now, when we divide 23 by 5, what will be the result? A quotient. Signal div will store this quotient, which is of integer data type. Now let's see the operation. A divided by B and storing the result inside this signal div. When we divide 23 by 5, what will be the quotient? 4.6. But here, signal div will have the value 4, a whole number, because signal div is an integer data type, and we all know that integer data type does not include decimal part. In order to include the decimal part, we need to change the data type. Example, here I am taking two signals x and y with data type real and the same value x equals to 23 and y equals to 5, and creating another signal named quotient with real data type to store the quotient. Here when we perform the operation, x divided by y means 23 divided by 5. Now this time quotient will have the value 4.6. So I hope the difference is clear to you. But what if I try to store this a divided by b, means integer a divided by integer b, and try to store this output inside this signal quotient, which is of real data type? What will happen? It will generate an error because VHDL is strict. We cannot mix different data types. So I hope the difference is clear to you. So this was division operator. Let's see the fifth one, modulus operator, represented by mod keyword. Modulus operator gives the remainder after the floor division. As we discussed that a division will give two results, a quotient and a remainder. Now, modulus operator gives the remainder after the floor division. Now, what is floor division? We will understand this in some time. First, let's try to understand how to use this mod keyword in VHDL. For that, I am taking two signals, A as integer 10 and B as integer 3. Signal result will store the remainder after the division, which is of an integer data type. Now let's see how to use the keyword mod. Here I am assigning A mod B and storing the result, that is, storing the remainder inside this signal named result. Now when we divide 10 by 3, what will be the remainder? 1. So this signal named result will have the value 1. So I hope you understand how to use this mod keyword. Now let's see the sixth operator, the remainder operator, represented by rem keyword. Now remainder operator gives the remainder after the truncate division. That is, remainder operator also gives the remainder after the division. But truncate division. Now what is truncate division? Don't worry, we will understand this in some time. First, let's understand how to use the keyword rem. For that, I am taking the two signals A and B, A as integer 10, B as integer 3. Signal result will store the remainder after the division, which is of an integer data type. Now let's see how to use the keyword rem. Here I am assigning A rem B and storing the output inside this signal named result. Now when we divide 10 by 3, what will be the remainder? 1. Therefore, this signal result will have the value 1. So I hope it is clear how to use the rem keyword. Now, what is the difference between modulus operator and remainder operator? Modulus operator follows floor division, while remainder operator follows truncate division. In floor division, result always has the sign of divisor. Means, result, here we can see plus 1 has the same sign as of divisor, plus 3. While in truncate division, result always has the sign of dividend. Here the result plus 1 has the same sign as of plus 10, the dividend. Now, what is the main difference? Let's understand this using an example. Here I am taking another signal C with integer minus 10. And if I perform the modulus operation here, C mod B, that is minus 10 mod 3. In floor division, when we have a negative dividend, then we take multiple of divisor, which is closest and smallest compared to the dividend. That is, multiple of 3, which is closest and smallest compared to minus 10. Example, minus 9. Minus 9 is closest to minus 10, but it is not smallest compared to minus 10. Next multiple, minus 12. Minus 12 is closest to minus 10 and also smallest compared to minus 10. And the difference between minus 12 and minus 10 will be our answer. Difference between minus 12 and minus 10 is 2. And we can clearly recheck that the sign of the result is same as divisor, which is B, that is plus 3. So I hope it is clear how to perform a floor division. Now let's see truncate division. Truncate division is like a normal division. When we take the signal C as integer -10 and perform the remainder operation, C rem B -10 rem 3, it will follow the normal division. When we divide -10 by 3, the remainder will be -1. And here we can clearly recheck that the result has the same sign of dividend -10 and -1. So, truncate division act like normal division. So, I hope it is clear the difference between modulus operator and remainder operator. Now, let's see the seventh operator and the last one, exponent operator. Exponent operator is used to raise a numeric base to a specific power. Means exponent operator is used to calculate the power of a number, where left operand act as the base and the right operand act as the power. Let's understand this using an example. Consider if I want to calculate 2 to the power 3. For that, I will take two signals A as integer 2 and B as integer 3. I will declare signal exp with integer data type to store the result. Now, let's see how to use the exponent operator. Here I am assigning A exponent B. Now, left operand A will act as the base and the right operand B will act as the power. That is 2 to the power 3, and store the result inside this signal exp. Now, exp will have the value 2 to the power 3, which is equal to 8. So, I hope it is clear how to use the exponent operator. Now, before I end this lecture, I have a homework for you. Question: calculate the modulus of -13 with 4 using the VHDL mod operator. Means calculate -13 mod 4 and post your answer in the comments. Now we are done with this topic of arithmetic operators, which means we are done with this lecture. I will see you in the next one. Thank you.